Okay, so if you're back, you're checking in to see if you did problem 2 correctly, and so I'm going to show you the answers kind of right away. And if you got them, you can move on with your life, and if you did not get them, then you can hang around and figure out how to get it done. Okay, so we start with this problem, Emily's painting, okay? And they ask us to write an equation in terms of A and T, where A is the area she paints and T is the minutes. So this is the equation you should have come up with. If you got this equation, then you can move on to later in the video where I go over the table. If you didn't get this equation, then stick around, let's do it together. Okay, so first off, they tell us that Emily is painting at a constant rate. Okay, a rate is a fraction that compares how one thing is being done in a certain amount of time. So in this case, she's painting square footage, and she can paint 32 square feet in 5 minutes. So I know in this problem they're talking about area that's painted in a certain amount of minutes. And so if I wanted to know my constant rate, I would take the area that she's painting, 32, and I would divide it by the time, 5 minutes. So this is feet squared, and this is minutes. If I wanted to make an equation out of this, then I would have to set it equal to the variables that are representing those values. So in this problem, it tells me that A is representing the area, so I'm going to put A on top. And T is representing the minutes, so I'm going to put T on the bottom. When I do this, this allows me to actually make a linear equation. Actually, this is a linear equation. The only thing I have to do is move this T. Okay, I move that T by multiplying both sides by T. Just like that. Cancel here. And we can write our final equation, which would be that the area is 32 over 5 times T minutes. Okay, so the number 32 over 5 is what we call the constant rate. That's the rate at which she can paint. So the next thing we're going to look at is the table. So I'm going to fast forward a little bit, show you what the table should look like. If you got all the answers in the table correct, then you can scoot forward a little bit to see what I'm talking about with the graph. So the answers that you should have gotten in the table are 0, 6.4, 12.8, 19.2, and 25.6. Okay, if you got those, great. Scoot forward in the video a little bit. If you did not get those, hang around. Let's see how we got these. Okay, so all we have to do is we have to plug in the time for the T and do the math. So A equals 32 over 5 times 0. We should know that anything times 0 is 0. That's how we get that point. Okay, A equals 32 over 5 times 1. Well, that's just 32 over 5, so what I did is I divided it. So if you do 32 inside, 5 outside, you should get 6.4. Okay, now I would like to say that I did that same math for every other problem, but to be honest, I didn't. I'm going to tell you why I didn't. Because I know 32 times 1 is 6.4. So if I'm doing times 2, that should be 6.4 more. So instead of doing this math here, I actually just added 6.4 each time to get my next answer. But if you want to do the math, you can. This would be 64 over 5. If you divide it, you'll get that answer. Okay. The next one would be 96 over 5. And if you divide that, you'll get your answer. And the last one would be 128 over 5, which will be that answer. Okay, so if you got that, great. Let's move on to actually putting this on our graph here. So our first point is this point here, which is 0, 0, which is right down here. So I'll put a dot there. Our next one is 1.61 and then 6.4. So I'm going to go to 1. You'll see here, pay attention, they're counting by 2's. So if I wanted to count, it'd actually be 1, 2, 3, 4, 5, 6, 7, 8. If I want 6.4, it's not going to be in the kind of towards the middle like I would normally think. It's actually going to be in the middle, kind of a fourth of the way there. So I'm going to put that kind of messed up, but right there somewhere is another point. Okay, and then we're looking at 2 and 12.8. So here's 12, and again this one will be closer to the middle, so I'm going to zoom in there now. 12.8 would probably be about right there. And then we have 3 and 19.2. So here's 3, here's 18. 19's in the middle, so just a little bit above the middle should be 19.2. So I'm going to say maybe right there. And then our last one is 4 and 25.6. So I'm going to go to 4 for my time and up to 25.6. So here's 24. 25 will be in the middle. So 25.6 will be in the third quarter that we have there. 25.6 would probably be about there. And that gives me the points that match this equation. So our last part is about how many square feet can Emily paint in 2.5 minutes. Okay, they want to know how much she's going to paint in 2.5 minutes. So they told me the time. They want me to figure out how much she's going to paint. So A equals 32 over 5 times 2.5, right? This is our time, the time that they gave us. So one thing I'm going to do is I'm going to do check method here. I'm going to write this as a mixed number. So this is going to be 32 over 5 times 5 over 2. When I do that, this will cancel out. 5 divided by 5 cancels out. We get left with 32 over 2, which we should know is 16. Okay, so this lets me know that she should be able to paint about 16 square feet in 2.5 minutes, which kind of makes sense because 2.5 minutes is between 2 and 3, right? And 16 happens to be between 12 and 19. So it kind of makes sense.